We're constantly swimming in a sea of averages. The average salary, the average time it takes to get to work, the average score on a test. We use them all the time to make these quick judgments about the world. But what if I told you that this one simple number, the average, can be both perfectly accurate and, at the same time, completely misleading? Let's dig into what averages are really telling us, and more importantly, what they might be hiding. Think about it. An average is basically a shortcut, right? It takes this huge, messy pile of information and just boils it all down to one single, easy-to-digest number. It's designed to give us the typical case, a simple summary of what's going on. But, well, as we all know, shortcuts can sometimes lead us way off track. So here's the real question. Is that one number the whole story? Can it actually be technically correct and, at the same time, paint an incredibly deceptive picture? The answer is a huge yes, and that's exactly what we're going to break down right now. Okay, so to get started, let's just look at the tools we use to find that so-called typical value in a whole mess of data. This is all about finding the center of the story. Now, the formal term for this is central tendency. I know, it's a bit of a fancy phrase, but it just means we're trying to find the middle, the most representative point in our data. And there are three main ways we do this. First up is the one we all know, the mean. This is what pretty much everyone is talking about when they say average. You just add everything up, divide by how many things you added. Super simple. Next, we have the median. All you do is line up all your numbers from smallest to largest, and the median is the one sitting right smack in the middle. It's the true halfway point, and as we're about to see, it's not as easily fooled by really high or really low numbers. And finally, there's the mode. This one is maybe the simplest of all. It's just the value that shows up most often. Think about it. If you own a shoe store, you don't really care about the average shoe size. You care about the mode, the size you sell the most of. So we've got these three tools to find the center. But this is where it gets really interesting. We're about to see how one of these tools, our good old friend the average, can create two totally different pictures of reality, even when the number is exactly the same. Let's look at a scenario. Imagine a teacher has two groups of students, Group A and Group B. They both take the same exact test. When the teacher calculates the mean, or the average score, for each group, they're both exactly 20. Now, based on that single number, you'd probably think, okay, both groups performed pretty much the same, right? I mean, their average performance is identical. But is it really? And here is where the problem just smacks you in the face. When we actually look at the individual scores, the story completely flips. Group A is all over the place. You've got scores way up high, way down low. Their performance is just erratic. But then look at Group B. It's this tight, consistent cluster. Almost every single student scored right around that average of 20. So here's the big takeaway. That average score of 20, it was a fantastic description for the typical student in Group B. But for Group A, it didn't represent a single student's real experience. The average completely hid the most important part of the story, the spread. So clearly, knowing where the center is, it's just not enough. We need another tool in our toolkit, one that tells us how spread out all the data is. And this brings us to the second hero of our story, dispersion. Dispersion, or you might hear it called variability, that's the term for this. It's basically a number that answers the question, are all the data points clustered tightly together, like in Group B, or are they scattered to the winds, like in Group A? Now, the simplest way to measure this spread is called the range. You literally just take the highest score and subtract the lowest one. For our chaotic Group A, the range is a massive 34 points. But for consistent Group B, it's just a tiny 6 points. See, now we're getting somewhere. This one number already tells us these groups are very, very different. But the range is kind of a blunt instrument. It only cares about the two most extreme scores, and it completely ignores everything that's happening in the middle. One single weird score, what we call an outlier, can make the range huge, even if everyone else is packed together. We need a smarter tool. And that smarter tool is the standard deviation. Now, I know, this sounds complicated, but the idea behind it is actually pretty simple. Instead of just looking at the two endpoints, it looks at every single data point and asks, on average, how far is each student's score from that mean of 20? It's a much more robust, much more honest measure of the overall spread. So a large standard deviation means the scores, on average, are far away from the mean. That's our Group A. Their performance is all over the map, totally inconsistent. A small standard deviation means the scores are all huddled up close to the mean. That's Group B. Their performance is super consistent. So, this brings us to the final and most crucial point. To get a true, honest understanding of any set of data, a single number is almost never enough. You really need to look at two. You need a measure of central tendency, like the mean or the median, to tell you where the center of the action is. And you absolutely need a measure of dispersion, like the standard deviation, to tell you how spread out everything is around that center. They're a team. It's a package deal. Together, and only together, do they give you the complete picture. Okay, so why does any of this actually matter outside of a math class? Well, imagine you see a headline like this one, which is based on a real study. On average, video games improved the mental functioning of the elderly. I mean, that sounds amazing, right? A clear success story. But now you know better. Now you know to ask that crucial follow-up question. Was that improvement consistent across the whole group with a nice, small standard deviation? Or did one person have a massive, once-in-a-lifetime improvement that just dragged the whole average up, while pretty much everyone else got no benefit at all? The average alone will never tell you that. But from now on, you'll know to ask for the whole story.